You're about to enter a world that even the greatest scientists find deeply unsettling. A world where reality behaves like a shape-shifting phantom, where simply looking at something can change it, and a single object can be in two opposite states at the same time. It sounds like science fiction, but it's actually how our universe works at the smallest scales. In this quantum realm, common sense breaks down completely. Particles don't behave like neat little billiard balls. They act as if they have minds of their own. This isn't a fringe theory, it's reality, tested and confirmed. And it's bizarre enough to make even the experts question what real really means. So what exactly makes the quantum world so unsettling? Let's begin with the disappearance of certainty. Down at the scale of atoms and electrons, the idea of a definite, predictable reality just falls apart. For example, you can know where a tiny particle is, or you can know how fast it's moving, but the universe won't let you know both with perfect precision at the same time. The more precisely you pin down one, the more the other flies off into mystery. It's as if nature built a fundamental fuzziness into reality that no amount of effort can overcome. And this isn't because our microscopes or measurements aren't good enough. This uncertainty is fundamental, a built-in limit in the universe. Reality, at its core, refuses to be fully pinned down. Think about that for a second. The universe keeps certain details inherently vague, no matter how hard we try to nail them down. As if uncertainty wasn't strange enough, the quantum world has another trick up its sleeve: superposition. This means a particle can exist in multiple states at once. It could be in two places simultaneously, or spinning in opposite directions at the same time, at least until you check on it. It sounds impossible, like a magic trick, but experiments show this is exactly what nature does on the tiniest scales. So what happens when you finally look? The instant you observe that particle, the haze of possibilities collapses into one concrete reality. It's as if by asking the universe a question, you make it settle on an answer. Before you looked, the particle wasn't just unknown, it truly hadn't decided yet. Your observation forces nature to pick a lane. Need an example? Picture this: a perfectly ordinary cat sitting in a sealed box. Inside that box is a devilish quantum device that, completely at random, either kills the cat or leaves it unharmed. Here's the twisted part. Until someone opens the box to check, the rules of quantum physics say that cat is, in a sense, both alive and dead at the same time. Sounds like a nightmare scenario, right? This is the famous Schrödinger's cat thought experiment, and it was designed to make your jaw drop. Schrödinger proposed it to highlight how absurd superposition can be when you extend it to everyday objects. If you really follow the quantum rules, even something as clear-cut as alive versus dead becomes maddeningly blurry. It's a paradox that shows just how insane reality can get when we peek behind the curtain. For the record, no one is literally doing this to cats. It's just a thought experiment, thank goodness. But it perfectly captures how disturbing the quantum picture is. The notion that reality might hang in limbo, that existence could be neither here nor there until someone looks, is the kind of idea that can keep you up at night. And it's not just you or me feeling that way. It makes scientists deeply uneasy too. As if superposition weren't enough, there's also entanglement. A phenomenon so strange it made Einstein uneasy. Entanglement is like a secret link between two particles. You poke one particle here, and its partner might react instantly, even if it's on the other side of the world, or the galaxy. Einstein famously derided it as spooky action at a distance, and you can see why. Think about how wild that is. Somehow, two particles far apart seem to know about each other instantly. There's no obvious signal between them, yet they behave as one. This idea flew in the face of everything scientists thought they knew about cause and effect. Einstein himself hoped it wasn't true. But experiment after experiment has shown that entanglement is very real. The universe, it turns out, allows a kind of connectivity that laughs at ordinary boundaries. For scientists, seeing entanglement in action was like discovering the universe has secret backchannels. It's as if two particles become twin souls. Whatever happens to one, the other knows instantly. That isn't just intriguing, it's a little terrifying because it hints that the universe has invisible connections woven through it, linking things in ways we never imagined. After hearing all this, you might be wondering, is there any solid ground left in reality at all? Well, funny enough, even the idea of solid particles has basically melted away. Modern physics tells us that particles aren't little nuggets of stuff at all. They're excitations in invisible fields that fill space. Think of these fields like an ocean spread throughout the universe, and a particle is just a tiny ripple on that cosmic sea. For example, take electrons. There's an electron field stretching across the entire universe, and what we call an electron particle is just a tiny excitation, a little ripple, in that field. The same is true for other particles, like quarks or photons. Each is basically a wave in its own underlying field. And what does that mean for empty space? It means the vacuum isn't truly empty at all. Instead of a perfect void, it's more like a silent symphony of fields, all humming with potential energy. Your chair, your body, the air you breathe. Zoom in deep enough, and you'll find they're nothing but vibrations in these invisible fields. The solidity we take for granted is really just an illusion created by microscopic dances of energy. Take a step back and think about what all this means. The solid world around you is mostly empty space, held together by invisible fields. The particles we imagined as little billiard balls are actually fuzzy waves of possibility that don't even pick a definite state until observed. Cause and effect isn't as tidy as we thought, because sometimes things just happen by quantum chance. The idea that objects are separate, toss that out too. Two things can be entangled and act like one, even miles apart. In short, reality is acting less like a clockwork machine and more like a bizarre, mind-bending puzzle, turning our ordinary expectations completely upside down. For a scientist, or anyone, trying to make sense of this, it's equal parts thrilling and disorienting. Thrilling because we're uncovering truths about the universe that are beyond wild. Disorienting because those truths shatter our intuitive understanding of reality. It's like realizing the solid ground under your feet has been a mirage all along. The deeper you dig, the more reality slips through your fingers, and that feeling can give even the brightest minds a kind of existential vertigo. Now, you might wonder, can reality really be this weird, or are we just talking crazy? Here's the thing, quantum physics isn't just wild speculation, it's the most accurate scientific theory ever tested. Every experiment we throw at it confirms these bizarre predictions. In fact, the very device you are using to watch this, your phone, your computer, works only because of quantum mechanics. We've harnessed these principles for technology. So this isn't some abstract thought exercise. This is truly how our universe operates, whether we like it or not. So yes, this theory works. But what does it actually mean for reality? That's the million-dollar question. We have equations that let us predict these phenomena with incredible accuracy. But when it comes to explaining why or how it all happens, even scientists start scratching their heads. For nearly a century, the greatest minds have debated what's really going on behind the math. Quantum mechanics gives us the numbers, but it kind of shrugs when asked for the story. The honest truth is, no one knows for sure what all of this really means on the deepest level. Take one common viewpoint, often called the Copenhagen interpretation. It basically says, Stop trying to picture an electron as being here or there before you look. Before observation, it's just a cloud of possibilities, not a concrete thing. Only when you measure it does it choose a definite state. In this view, the act of observation is what brings reality into focus. It's a weird idea, absolutely. But for a long time, that was basically the party line. In other words, don't ask what's really happening behind the scenes. Just trust the math and carry on. That's how many physicists learned to stop worrying and love the quantum, so to speak. Others weren't satisfied with observer magic and proposed something even more radical: the many worlds interpretation. This idea says the universe doesn't pick a single outcome when a measurement happens. Instead, it splits into multiple realities for every outcome. In one branch of the multiverse, the cat is alive. In another, it's dead. Every quantum event, no matter how small, spawns new parallel worlds for each possibility. Think about what that implies. There could be countless versions of you in countless parallel universes, living out every alternative possibility. It's a mind-bending thought, almost impossible to fully imagine. It sounds like science fiction, yet many serious physicists consider it plausible. The appeal of this view is that it removes the need for an observer to collapse anything. No outcome is lost. The universe simply forks into all of them. To some, that's actually less crazy than believing our observation magically creates reality. Instead, every possibility is real somewhere, and we just happen to experience one path of this cosmic multiverse. Then there were those, Einstein included, who felt something crucial was missing, as if there must be hidden pieces to this puzzle to make it all make sense. They proposed hidden variables, unseen factors or mechanisms that secretly decide outcomes and put some order back into the quantum chaos. Others suggested the pilot wave theory, imagining that particles are guided by an invisible wave, giving a subtle underlying structure to their behavior. All these ideas aim to make quantum physics feel a bit more normal. They're basically saying, maybe it's not truly random or undefined. Maybe there's a hidden layer we just don't see. But so far, there's no solid evidence for any such hidden clockwork. The quantum weirdness stands on its own. And then comes a truly provocative question. What if consciousness itself is the missing piece? Could a conscious mind be needed to collapse those quantum possibilities into reality? This idea is highly controversial, since it drifts toward philosophy and even mysticism. Most physicists are skeptical of the notion that mind over matter plays any role in quantum physics. Still, the mere fact that we even ask whether the universe needs an observer to exist shows how strange this all is. Quantum theory blurs the line between observer and observed in a way no other science does, and that alone is enough to make us question reality in a deep way. So where does all of this leave us? It leaves us with a universe far stranger than we ever imagined. Sure, it can be disorienting, even a little scary, to realize the bedrock of reality is so slippery. But it's also awe-inspiring. It means there's so much more to learn, so many mysteries waiting in the dark. The unknown is vast, and for a curious mind, that's not a horror. It's an invitation. Even the scientists who feel unsettled by quantum mechanics can't help but be excited. That jolt of fear is just the flip side of awe. It's what you feel standing at the edge of a vast unknown, a mix of vertigo and exhilaration. It reminds us that there is still magic in the world. Not hocus pocus, but real, natural magic hidden in the fabric of reality, waiting for us to uncover it. What could be more exciting than that? And what about us, you and me, just trying to make sense of our place in all this? We might not solve the mysteries of quantum physics on our own, but simply understanding how strange reality truly is can change our perspective on life. It's humbling to realize our everyday experience is just a thin slice of what's out there. It encourages us to stay curious and open-minded, knowing that the universe is full of surprises. If the fabric of reality is this bizarre at its core, imagine what other wonders might be waiting for us as we continue to explore. In a strange way, quantum physics also teaches us about embracing uncertainty. We all love clear answers and solid ground, but the universe is telling us that ambiguity is part of its nature. And yet, even without complete certainty, scientists have managed to harness quantum laws to achieve amazing things. It shows you don't need to have all the answers to move forward. Sometimes, you just have to embrace the mystery, stay curious, and keep exploring. So if quantum reality leaves you feeling a bit shaken, that's okay. It means you're starting to grasp just how extraordinary the universe really is. Let that bit of fear humble you, but don't let it stop you. Let the wonder win out. Because the fact that reality is more fantastical than we ever imagined isn't just scary, it's deeply inspiring. It means there's so much more out there still to discover. Yes, the universe is strange and full of paradox. But in that strangeness lies inspiration. It means reality isn't mundane at all. It's richer and more mysterious than we ever thought, and that can be a beautiful thing. If this journey has resonated with you, keep that curiosity alive. Keep asking questions, even the ones that have no easy answers. Remember, every great discovery started with someone daring to wonder about the impossible. Let your questions guide you. Let your awe drive you forward. Here in our little community of curious minds, we encourage that spirit. We're all students of the universe, learning to find meaning even in the mysteries that make our heads spin. So the next time you feel your mind bending from a crazy idea like this, remember that's a sign you're growing. Your understanding is expanding beyond its old comfort zone. Lean into that feeling. Let the mystery motivate you rather than intimidate you. Trust your curiosity to guide you forward. Stay curious, stay open, and keep looking deeper. Because the more we explore, the more wonder we find in every corner of reality. Until next time, keep that sense of wonder alive. Who knows what you might discover out there?